going to discuss maintenance management, block 3, analytical methods and model, unit 8, reliabilities, availabilities, maintainabilities and RCMs. Moving to next ones. Before starting the session, we will understand what are the different objectives of today's sessions. To understand the concept of reliabilities, availabilities and maintainabilities. Then point number 2, establish the relationship between reliabilities, availabilities and maintainabilities. How this reliabilities, availabilities and maintainability help in case of maintenance management. That part we will understand. And what are the different relations with this reliabilities, availabilities and maintainability we will understand. Then point number 3, major reliabilities of the system having the component in series and component in parallel. So with respect to the maintenance management, we have to understand and measure the reliability of systems, especially referred to parallels and series of components. Then point number 4, understand the different factors which affect or affecting the maintainability or reliabilities. So these are the content of today's sessions. First one is introductions, then introduction about the reliabilities, introduction of availabilities, then maintainabilities, and the reliability center maintenance, which is shortly known as RCM. Then element of maintainabilities. The next we have introduction to reliability center maintenance. Then reliability center maintenance methodologies, benefits of implementation of reliability center maintenance in organizations. Then we have to understand the benefits of reliabilities, availabilities. Next we have maintainabilities and the reliabilities centered maintenance. The next we have mixed conception about the reliability centered maintenance, and we have to understand the different pitfalls of implementing the reliability centered maintenance. So let's start the session from the introduction point of view. So as far as concerned with maintenance management, the term reliabilities, availabilities and the maintainabilities, which is shortly known as RAM, is very important for the operational as well as maintenance personnel. So the RAM or reliabilities, availability, maintainabilities of equipments affect the productivity of manufacturing systems. So before starting this particular session, we have to understand how the validities versus reliabilities basically work in case of maintenance management. So if you observe this particular image, so reliabilities but not valids. In the first image, the error are just missing the targets or away from the targets. So in case of valids, some out of 5 number of arrows, 1 arrow is touch the target. It directly represents the valid but not reliables. And if you observe the last figures, the 5 number of arrow are directly focused towards or it is directly touch the target. That means valid and reliable. So this concept is also applied in case of maintenance management. So reliability means a machines or equipment is the probabilities that equipment will give failure-free performance, and it is intended function during that particular time. So during the production and operation management, in that cases, most of the cases we are basically use various kind of machines, and these machines consist of a particular workstation, and whenever you assign a particular machines, that machine will provide that is failure-free performance during the operations or during the production activities. So I repeat, reliabilities of a machines or equipment, that is the probability that the equipment will give failure-free performance. Then how the reliability should be measured? It is the mean time between the failures, which is shortly known as MTBPA, and it is the average time between 2 consecutive failures. This is all about the fundamental concept of reliabilities. I repeat, the failure-free performance basically intended during the functions of productions operation management is known as reliabilities of a specific machines or equipments, and it should be measured as the mean time between the failures. So if you go for the average time between 2 consecutive failures, that is known as reliabilities. So this is the fundamental concept of reliabilities. Moving to next ones, the next fundamental concept we have known as availabilities. So the machine or equipment may be highly reliable as the failure rate is negligible. It fails only one or two times in a given period. But in case of availabilities may be very bad because once it fails, it takes very long to repair. So the time taken to repair the concept of maintainability is known as availabilities. Moving to next one, the next point we have that is known as maintainabilities. So in case of maintainabilities, it is the characteristics of a design and installations which is expressed as the probabilities that an item will be restored to a specified conditions within a given period of time when the maintenance action is performed in accordance to the prescribed procedure and resources. So most of the cases, the mean time to repair, which is defined as the statistical mean of distribution of time to repair, is known as maintainabilities. So this is the overview of reliabilities, availability and maintainabilities. Being a maintenance management department, it is their role and responsibilities throughout the shift, throughout that is known as day and throughout the year. They have implementing the reliabilities, availabilities and maintainabilities so that there is error-free performance should be achieved in case of production and operation management, especially in reference to product-oriented plant. And here what will happen? They can reduce the time in case of availability of machines. They can maintain with reference to the design and installations, and the error-free performance will be observed in case of reliability to increase the healthy condition of machines and equipments. Moving to next ones. So before going to this particular introductions, we have to understand the different aspect of reliability, maintainability, reliability, maintenance, and maintainability with respect to productivity. So as far as concerned with the designs, design define the maintainabilities, and improvement is basically implement to modify the maintainabilities to improve the performance of machines as well as equipments. Then if you observe in case of reliability, that is the mean time between failures which affect various amount of strategy implement for the maintenance works. For example, we have corrective maintenance and we are also implementing preventive maintenance. So corrective maintenance affect the availability of machines, but in case of preventive maintenance will improve the availability of machines. And if you observe the availabilities that impact the productivities. So it is the duty of that is known as maintenance managers. They go for higher side of improvement of maintainabilities, which affect the corrective maintenance as well as preventive maintenance, which leads towards improve the availabilities and impact upon the productivities. So this is the simple schematic of your reliabilities, maintenance, maintainabilities. Moving to next one. The next one is the introduction of reliability center maintenance. So if you go for the classification of this particular reliability center maintenance, or which is shortly known as RCM, the RCM strategy employed preventive, predictive, proactive maintenance technologies is an integrated manner to increase confidence that machines will operate dependable over the extended life cycles. So along with the preventive, predictive and proactive approaches, this reliability center maintenance philosophies, which includes the knowledge-based diagnosis of the samples to incorporate a learning component within the programs. So most of the cases, it is basically employed for preventive maintenance, predictive maintenance, as well as proactive maintenance. So let's understand the classification of your reliability center maintenance. So they are classified into four categories. The first one is that is known as reactive. That means it is basically includes small items, non-critical items, insequentials, unlikely to fail, and redundant. Similarly, if you go to the second class, that is known as intervals. So in interval, we are basically implement the preventive maintenance, which basically includes the subject to wear outs, consumable replacements, failure patterns should be known. So for example, there is a welding joint. In that case, you have to take about the preventive maintenance to identify the different patterns of failures in case of joining of weld, especially reference to pipelines, especially reference to machines or components. The next we have CBM, which is known as condition-based maintenance, which includes to identify the random failure patterns not subject to wear and preventive maintenance introduce failures. And the last class we have that is known as proactives. So in case of proactives, we are basically implement that is known as RCFA, that stand for root cause failure analysis, age explorations. The next is failure mode and effect analysis, which is shortly known as FMEAs, and the last one is acceptance testings. So these are the classification of the reliability centered maintenance, which basically employed for preventive, predictive, and proactive maintenance technologies to increase the operator dependability over the extended life of machines. Moving to next one. So whenever you go for the reliability, first you have to focus upon the basic concept of reliability. That means it is the probability of a product or equipment or process or system performing its intended functions for a stated period of time under certain specified conditions. For example, you are using a pump, and pump is basically operated in a specified conditions, specified environments, and the intended function of pump that stated a given period of time. That means that should be run for that is known as 24 hours or maybe 8 hours or maybe 10 hours. So whenever you go for the details of reliabilities, you have to understand the four aspects of reliabilities. That means reliability is a probability based concept. The numerical value of reliability should be lie between 0 and 1s. This is the first aspect. The second aspect we have the functional performance of product to meet the certain stipulations. That means product design will usually ensure the development of a product and that meet or exceed the stipulated requirements. So there you have given the example of pump, or if you take the example of gearbox. So the intended function of gearbox is they'll basically transform the power from engine to the number of the known as wheels. So they basically transform the power or mechanical power from one state to other states. So the third aspect that is known as reliability implies the successful operation over a certain period of time. So whenever you apply this particular concept, that is known as probability based concept, that must be successfully operations over a certain period of time. Suppose you run a machine for 8-hour shift or you run a machine for 12-hour shift. So that certain period should be successfully operations or the ability should be implying of the successful operation of that particular machine or equipment. The fourth aspect we have that is known as operating or environmental condition under which the product used to take place specified. So here the operating condition is given. So most of the cases when reliability is concerned, especially reference to probability based concept, which basically the numerical value will lie between 0 to 1. So in that cases, the environment should be that is known as free of dust for a machines. There should be proper spacing should be provided so that the operator or operating condition should be achieved or the performance of machine should be achieved. So these four aspects should be basically focused upon the reliabilities. So moving to next important part, if you go for short summarization of reliabilities. So the first, if you observe this particular figures, the first important thing, it's a probability based concept. It is basically focused to increase the durability of machines. The next important part is it is basically focused upon the intended function of dependability of operations and quality over the times. And the last one is availability of machines. These are the concept of your reliabilities. I repeat, the reliability is the probability of a product, equipment, process or system performing its intended function for a stated period of time under certain specified conditions. So here specified condition means operating condition of that particular machines. Moving to next ones. So let's take an example of reliabilities. So if you take the cases of earth moving equipments, which consist of various complex parts, starting from the moving arms, then number of gearboxes, hydraulics are there, engines is there. So let's take this particular earth moving, which have more than 5 number of parts in series, or reliability should be each part is 99.5%. I repeat, consider the equipments. So here the equipments is the earth moving equipments with 500 parts in series, and reliability of each part is given, that is known as 99.5%. So the next important part is the reliability of this equipment would be 0.995, that is 500, which comes out the unexpected low value of 8%. So let's consider the equipment would be 0.995, that is of 500, which comes out at the unexpected low value of 8%. So no one would accept the such equipment which has more than 92% of failure chances. So out of unexpected low values, that is 100 minus 8%, that equals to 99% of failure chances. So thus the reliability of function of complexity is the number of components. So whenever you go for measure the reliability of machines, equipments, system or process, each process or each system consists of number of series of parts, and each series of parts have unexpected low values after certain time periods. So that time period should be calculated from hundreds. That means your failure chances will be increased up to 92%. So the manufacturing of equipments and its repair method should be most of the parts have 100% reliabilities. So in that cases, if the percentage of failure is increased in that cases, the manufacturing of equipments and its repair method should be such that most of the parts have 100% reliability. So this is the concept of reliability which is implemented for a system, for equipments, for a process, or for moving to next ones. So let's understand how this reliability is basically considered. Whenever you go for that is the improvement of reliability is a continuous engineering process. It involves the numerous amount of data collections, data analysis. We find out the mode of failures in various places on the equipments. So if you use the data analytics, there is a method that is known as Pareto principle is applied. Under Pareto principles, that is 20%, 80% method is applied. That means 20% effort should be done and 80% result will be come out from the reliabilities. So as far as concerned with the production departments, using the equipments, the next is maintenance departments, the equipments manufacturers, the designer of equipments are fed with the data for the necessary actions to improve the reliability. So for example, a maintenance department is recently purchased that is known as pneumatic cylinder, and the cylinder must specify the various form of data, and that data should be shared to production departments as well as maintenance departments, the equipment manufacturers, and the designer for necessary action to improve the reliabilities. That means reduce the chances of failures. And most of the cases, the Pareto analysis is used to separate the critical components, parts, which fail too frequently. For example, in case of gearboxes, you are basically using number of or a vast number of that is known as O-rings are there or oil seals are there. So most of the cases, whenever excess amount of stress on this particular machines, in that cases the oil seal are basically tears. So you have to identify those components and segregate this critical component so that the fail too frequently or which has greater impact on the availability of equipments. So you have to segregate the number of component, and out of the number of component you have to identify which component fail frequently, so that you can, there is huge amount of impact should be reduced, especially reference to equipments. So this is called 80-20 analysis, where 20% parts account for 80% of failures. So you have to reduce that particular segregate critical component from the machine so that you have to reduce the percentage of failures. So this is the basic concept behind the Pareto analysis. Moving to next one. The next one is approaches used to enhance reliabilities. So what kind of approaches? So using thicker materials, stronger, better material for light purpose equipments, simple and standardized components and parts. So how to use this approach? So for example, retest the approach, parallel form approach, decision consistency approach, iterators approach are basically used to enhance the reliabilities. so that the designer, the production department, the maintenance departments, the parts supplier should understand how to improve the product. So for improvement of product or machines or equipments, they can use light materials, which is very much stronger and better material for light proposed equipments. So another aspect of enhance the reliability that you can go for simplification of your component, standardize the component so that the failure chances will be reduced. Moving to next one, to understand the different approaches enhance the reliabilities, you have to understand the different types of reliabilities. So we have two types of reliabilities are there. One is external reliabilities and internal reliabilities. So in case of externals, it extends to which measures varies from one use to another. So here you can use the test, the retest measures that stabilize the test over the times. And inter-raters, that means the degree to which the different rates given consistent estimation to the same behaviors of different components and parts. If you move to the next, that is known as type of reliabilities. So we have extended to which measure is considered within itself, and here split the half method. That means measure the extended to which all parts of the test contribute equal what is being measured. So whenever you go for measuring the reliabilities, you have to focus upon two aspects, that is known as internal as well as externals. Moving to next one. To understand the reliabilities, many organizations are also use the bath tube curve. So let's understand the bath tube curve. So if you observe this particular image, the concept of bath tube curve is a graphical presentation of field of reliabilities, which consists of three number of that is known as component. The first component is early failures. The second component we have normal life, and the third component we have wear out the sections. So to measure the three components, we have two parameters are there. One is failure rate versus times. So if you go to the fundamental concept of bath tube curve, which is applied in the field of reliabilities, so it is a famous graphical presentation of reliabilities, and this curve basically plotted in between product failure rate versus the times. So the resulting curve describes not only the behavioral of engineering component but also the lifetime of the human populations. So these are also applied to the various fields. So this is also called failure rate curve, for which the failure is plotted as a function of times, and bath tube curve is generally graph that is used to graphical demonstrate run to failure maintenance strategies. And this curve simply represents the overall life cycle of asset, failure rate of overall populations over the asset over times. So bath tube curve is usually considered to be one of the most useful and essential graphical presentations of reliability of assets. So it is divided into, as I told, in three different sections: early failures, normal life, and wear out sections. By comparing the failure rate versus the times of a specific, that is known as machines or lifetime of a machines or engineering component, basically measured through the bath tube curve. So let's take an example of a that is known as a mixture which is used in our day-to-day life. So for example, during the initial days, the early failure should not be measured, or the chances of early failure is less, and after some period it provides the normal life. That means the span of life should be large in between maximum 5 to 10 years. So after 10 years, certain amount of wear out section should be identified. So just like product life cycles, this bath tube curve also presents the graphical field of reliability, which basically intended towards the intended function of the mixtures. So after wear out sections, if you find there is certain amount of reliability should be observed by replacing the components, or by that is known as replace of different components like motors or blades, you can also prevent a certain amount of failure by measuring the reliabilities. Moving to next one. So first, as I told that we the bath tube curve has three number of failures. So first, understand what is early failures. So infant mortality sections is simply referred to the early failure, or initial part of the bath tube curve is also known as early failures. So by seeing the curve, one can easily understands that in this section the asset is beginning with its uses for the first time, and initial failure rate, that is the probability of failure occurrence, is very high. With increase in time, they gradually decrease the failure rates. So in this section, the failure are usually occurs and due to manufacturing defect, installation issues, design issues, material defects, or improper startup procedure, etc. So we also take an example of that is known as ceiling fan. So whenever you consider the ceiling fan under the parameter or first section, that is known as infant mortality. So during the beginning of the or the switch on the ceiling fan, we can find a number of failures. So failures are in the form of that is known as manufacturing defects in case of blades, or in case of that is known as the coil casings, or maybe the failure should be occur in case of installation issues. There should be some design issues we consider. For example, the length of fan blade, the width of fan blades, and maybe the material defects. Suppose some company are using aluminum or cast alloys, so there may be some amount of wear and tear should be observed, or maybe the installation or starting procedures should be followed. So whenever you use continuously, it should be increase the number of the knowledge, increase the time of that particular fan, and decrease the failure rates. So after early failures due to manufacturing defects, installation issues, design issues, material defects, and improper startup procedures, it should lead towards the normal lives. So let's see what happens in case of normal lives. So normal life section is simply referred to as the usual life period or steady state operations. So this section represents the normal operating life of assets. By seeing the curve, one can easily understand that in this section the asset still experience the failure, but normal and low rates. So here what will happen? The failure rate is little bit lower sides, and in this section the failure are usually concerned with overloadings, hidden defects, collision with other objects, mistakes of personals, and failure rate is most constant in this particular page. So here failure rate may be constant. Moving to next ones. After normal life sections, the third section we have wear out sections. So in case of wear out section, it simply referred to the aging periods. As I told in case of product life cycles. So just like product life cycle, starting from the initials, then growth, then maturity and declines. So the last phase in case of PLC is very similar to the wear out sections, which is known as aging periods. So by seeing the curve, one can easily understand that in this section there is gradual increased failure rate of assets with increasing times. So how many times if you are using, that also leads to the aging period of the particular equipments and tools. So number of failures occurs experienced by the asset generally increase with the times. And in this section, the failure rates are usually occurs due to fatigues, wear, gradual deteriorations, and corrosions. So this period is simply represent the end of life cycle of the assets or end of life cycle of a fan or a grinders. So how to identify this kind of failures? For example, failure due to fatigues in case of wear and tear in case of gear and gearboxes, gradual deteriorations and corrosion due to that is known as less amount of lubrications, and that lead or end the life of this particular assets. So moving to next ones, the next ones is known as availabilities. So in the previous session, we have to understand what are the different aspect of reliabilities, the fundamental concept of reliabilities, and how the reliability is basically analyzed by the Pareto analysis, that means 20-80 analysis, and lastly by the help of bath tube curve in case of three components like early failures, then the next one is that is known as average life and wear out, that is known as reliability should be considered. So next we have to understand that is known as availabilities. So availabilities and maintainability jointly affect the equipment availability for the user. For example, in a workshop, there are a number of workstations are there. So each workstation consists of number of complex machines. So how to understand the availability? That means the reliabilities and maintainability of machines, equipments, they jointly affect the availability of users. So who are the users? Basically the operators are the users. So availability of high reliable equipment is reduced its poor maintainability. This is the most important concept which is applied under the RM, that is known as RAM, that means reliability, availability, and maintainability. For example, similar equipments may have poor maintainability, but if it is reliable, it's poor, and fail frequently can result in poor availabilities. So, for example, you are also using various kind of complex gearboxes, complex components, complex machines, and each equipments may have good maintainabilities. So, by providing that is known as preventive maintenance, proactive maintenance, and corrective maintenance, you have to achieve higher set of reliabilities. So if the reliability is poor, in that cases, the result in case of poor availabilities. So it is the duty of that is known as the manufacturer during the design stage, the operational availability requirement can be converted into reliabilities and maintainability requirement within the constant of the missions. So what is the constraint of the mission? For example, you are using various complex machines, just like your CNC machines. So CNC stands for computer numerical control machines. So many complex and precise parts are there. So if I go for 3-axis CNC machines, in that cases, the operational availabilities requirement can convert reliability and maintenance. Suppose you are using the CNC machines for longer amount of time, more than 5 years, more than 6 years, more than 10 years. So if you use more that is known as lifespan, in that cases, it convert the reliability and maintainability requirements. That means you have to implement the knowledge preventive maintenance, proactive maintenance, or maybe the knowledge corrective maintenance, so that within the constant you can achieve the missions of that particular machines. So there are several amount of alternative combination of reliability and maintainability can be obtained for any given availability levels. So let's understand this one from this particular graph. So this graph is plotted versus that is known as mean time to repair, which is known as maintainabilities, and failure per periods, that is the consecutive failures, which is known as reliabilities. So maintainability versus reliabilities, and you have given the operational suitable areas for specific machines or equipments. So if I increase the that is known as maintainability and the reliabilities, that directly affect the equipment availability for the users. So if I take care, or the maintenance department is take care about maintainability as well as reliabilities, in that cases the machines availabilities is ready for the users for next period of times. So this is the concept of availability which is implemented in various organizations to reduce the failures, and the next important part is maintain the time to repair whenever it is available. Moving to next one. So let's take examples in the working of a machines for 100 hours, and the availability of 95% can be achieved by 5 failures, each having a downtime of 1 hour. I repeat, in a working of a machines, any machine you can consider for 100 hours. Let's say a pump, water pump, which is running for 100 hours, and availability of that pump is 95%, and which can be achieved by 5, that is known as number of failures, and each failures have the downtime of 1 hour. So the alternatively failure of 10 with each downtimes of 30 minutes will give the availability of 95%. And both these rates may be told from the operational viewpoints. Or if you go for other alternatives, that means 95% availabilities is like 100 failures, each with the downtime of 3 minutes may be operationally suitable. So depending upon the consequence of maintenance or consequence of availabilities conditions which is applied to a specific machines which done 100 hours and provide the availability of 95% with the downtime of 1 hour for 5 consecutive failures. So here what will happen, these failure rates should be tolerated from the operational viewpoints. So during the 100-hour working of that pump should be suitable to that is going to spread the water to a specific areas, spread the water to the number of furnace, spread the water to the requirement of different departments. And if you observe in the alternative ways, so 95% availability like 100 failures and each failure of 3 minutes. So the total 30 minutes time should be there, and the 3 minutes should not be operationally suitable in that cases. So here what will happen? Whenever you go for availability of any machine and components, you must go for the that is known as tolerable range, which is suitable for operational viewpoints. And it is not suitable for operational viewpoint. In that cases, you have to go for that is known as maintainability as well as reliabilities. That means mean time to go for repairs and try to reduce the percentage of failures per periods. Moving to next ones. So how to calculate the availabilities? So the availability of the system that equals to mean time between failures divided by mean time between failure plus your mean time to repair plus your mean time waiting for the spares. So this is the typical formula which is applied for calculation of availabilities. So by reflecting the availability supply availabilities, the mathematical expression can be expressed as in case of input or output functions, that A equals to function of R, function of M and function of S. So A stands for availabilities, R stands for reliabilities, M stands for maintainabilities, and capital A stands for supply effectiveness. So these two formula can be used to calculate the availabilities. I repeat, so A equals to availability, that equals to mean time between failures whole divided by mean time to repair plus, so the mean time between failure plus mean time to repair plus mean time waiting for the spares. This is one formula. And if you go for reflecting the supply availabilities as the input output functions, so A equals to function of reliabilities, maintainabilities and supply effectiveness. So moving to next one, how to calculate the maintainability, reliability, maintenance. So the first important part is that from the design aspect, it defines the maintainabilities. If you want to go for modify, so the companies as well as the departments as well as the production department suggest for the modifications. So this modification provide the improvement in case of increase the maintainabilities of the machines, and maintainabilities directly affect the corrective maintenance, preventive maintenance, and corrective maintenance affect the availabilities that impact upon productivity cost. Similarly, preventive maintenance improve the availabilities that also impact the productivity cost. So comparison to the reliabilities affect the corrective maintenance, which affect the availabilities, and availability impact upon the productivity cost. So let's understand how the maintainability is basically used in case of that is known as improve improve the maintenance management, especially reference to corrective maintenance as well as preventive maintenance, which leads towards reduce the productivity cost. So the first point is maintainability is an obscure concept of unless derived from related purpose of the system or equipment. So as I told in case of the mathematical derived before it can be used in significant system specification. So what is system specifications? So the design should be very simple. It should be easily understood by the maintenance personnel, and the design must be maintenance free design so that less amount of maintenance work or less amount of that is known as equipment and spare is needed to keep the machine for healthy. So here what will happen, the maintainabilities may be given the less importance in one sort of application like missiles, like rockets, like propulsions where reliability is high importance. So in that cases, the maintainability is basically combine the qualitative as well as quantitative characteristics for the material design. So if you go for titanium materials, the maintainability is very much higher set as compared to alloy steels. So the next important point is installations. So if you use the standardized or standard operating principle or procedure for installations, it enables the operational objectives within the minimum expenditures. That means it's focused upon less amount of manpower. The next is personal skills, test the equipments, the technical data, and facilities under the operational environmental conditions in which the schedules and unscheduled maintenance will be performed. That means corrective and preventive maintenance would be scheduled. So whenever you go for higher set of maintainabilities, you have to combine various aspects. One is that is qualitative aspect as well as quantitative aspect. So in case of qualitatives, you have to go for that various amount of skills should be required in case of manpower. In case of quantitatives, you require technical data, In case of qualitative, number of facilities should be counted. The next is test the equipment, it is under quantitative statistics. To increase the schedule and unscheduled, that is known as maintenance, will be performed to increase the lifespan of the machine and equipments. So moving to next ones. So here some quantitative measures requirements are given. For example, maintenance man hours per 100 machines running hours. Then you have to calculate the turnaround time required for returning the machines to operational ready conditions. The percentage of components or modules which can be down for the maintenance and still permit the attainment of the operational requirements. And the other consequence can be also calculated in case of maintainability. The first one is that is known as down times, then maintenance times, then logistics requirements, then equipment damage, and the last one is you have to take care about the personal injuries. So whenever you focus upon that is known as quantitative measures, you have to calculate the man hours or machine running hours, then turnaround time required in case of operational ready conditions of the machines, and you have to also go for calculating the components or module which can be down for the maintenance or still permit the attainment of the operational requirements. So for this maintainability aspect, you have to also focus upon the intensity of consequences. So what are the consequences? We have downtime, we have maintenance times, we have logistic requirements, and we have equipment damage and personal injuries. So these consequences are also considered in case of maintainability. So let's understand how this thing should be basically applied in case of measuring the maintainability. The first important part is maintainability index. So you have to go for that known as calculating the different parameters of machines with reference to design specifications. Then code charts, you have to go for coding the machines. Then cyclometrics complexities. Then you have to focus upon time and resource constraints. So within the stipulated times, we have to increase the attainment of that is operational requirements. Then team collaboration should be there so that they can lead the particular teams and they can easily mobilize from one places to other places for maintenance work. And for every that is known as maintainability, you have to go for record keepings. This record basically used for that is known as machine designs, machine blueprints for present, past, as well as future reference. Then test the coverage, that means whether the maintainability is achieved within the limited periods. And lastly, go for the code duplications. So these are the different that is known as parameters basically used in case of measuring the maintainability. So moving to next ones. The next one, the element of maintainability. So in case of improvement of maintainability is an important aspect for design as well as maintenance departments. So various policy and decision related to maintainability can be classified. The first one is design decisions. That means whenever you focus upon design decisions, these elements should be considered. The first one is modular design of equipments. Then standard fasteners. Most of the company are basically used that is known as MS. Millimeter size fasteners. The limited variety and size of fasteners should be there. Interchangeability of component from one workstation to other workstation should be there. Good approach to detect and correct the fault. Quick opening arrangements. Use of component with fail-safe measures. Better labeling and color coding to prevent the wrong connections. So these are basically included in case of design decisions. The next we have that is known as maintenance policies. So every maintenance department has their standard operating policies. And under these policies, the first point or first element is included in repair versus discard. Then, if you go for repair, there must be a replacement policies. And if there is a replacement policies, the policies strictly define the spare parts policies. Then, after the replacement, the maintenance policy also include the condition monitoring. Then, proper instrument for monitoring of systems. Then use of torque, range and other efficient tools, or you can simply pronounce as use of hybrid tools. Then use of cranes and other lifting mechanism for heavy components. So under maintenance policies, this element must be there, which is basically leads the decision related to the maintainabilities. Then technician requirements. So under technician requirements, What are the different elements we have? The first one is that the technician must be educated. They have vast amount of experience, and aptitude of the technician is very clear towards the maintenance activities. Then training to technician to analyze the tasks and understand the procedures. And the last one is compatibility of man and the systems. So these are the different elements of the maintainabilities. Moving to next ones, the next topic we have that is known as reliability center maintenance. So this concept is introduced during 1970s by the Maintenance Steering Group of Commercial Airline Industries in order to reduce the maintenance downtimes and maintenance cost and improve the fire safety. So then after it is also introduced to many maintenance departments in various organizations, whether it should be small scale industries, medium scale industry or large scale industries. So how this maintenance or reliability center maintenance is implemented and what are the different decision is taken under the reliability center maintenance, you'll understand. The first important part is proactive maintenance. It also provides the real-time monitorings. It also provides the basics of condition-based maintenance, which is lead towards the predictive testing and inspection of various machines and tools. It also provides preventive maintenance, and for best maintenance decision, they are also reactive maintenance that is run to failures. So these are the different decision areas of the reliable center maintenance. So this RCM, or it is shortly known as RCM, whenever it is introduced to maintenance departments of a specific organizations, so they can use as a strategy, or this RCM basically use as a strategy to employ preventive, predictive and proactive maintenance technologies in an integrated manner to increase the confidence that machine will be achieve its intended functions or will operate dependable over an extended life cycles. So why this is most important part? The thing is that those who have complex organizations like integrated steel organizations or integrated very known as automotive organizations or automotive manufacturing organizations. So they are vastly using preventive maintenance, predictive maintenance and proactive maintenance technologies to increase the confidence of the machines so that they can achieve the intended function of that machines in a extended life cycles. So whenever they implement these three maintenance technologies, these are simply combines to form the reliability center maintenance. So here what will happen? They can use various form of advanced tools, various form of SOPs are there. They are also assigned various amount of sensors and which is used in case of condition-based monitoring, hybrid machines for analyze various amount of data. They compile and that is known as compiles number of data by the help of computer or numerical controls, and they will provide the large amount of maintenance related decision whether the company go for preventive maintenance or predictive maintenance or proactive maintenance. So the integrated approach of various technology is required as no single technology is sufficient to accurately understand the problem of complex equipments. So let's take an example of computer numerical control machines which have 6 number of axes. So these 6 axis CNC machines are vastly used for complex parts manufacturing. So if I implement preventive maintenance, it should not be sufficient. If I implement predictive maintenance solely, it is not sufficient to go for accurate understanding of the problems. So by combining the preventive, predictive and proactive maintenance technologies, or which is known as reliable center maintenance, in that cases, the complex problem should be easily understood of the complex of the equipments. So, however, in combinations of various technology provide a powerful set of capabilities which determine holistic picture of the machine health. So, by combining these three maintenance technology in the form of reliability center maintenance, you can easily increase the life as well as conditions of the machines, which is provide a better that is known as machine health, especially reference to improve that is known as the performance of the machines, reduce the maintenance downtime, and also reduce the maintenance cost, which is very much important. And the last important part is improve the machine safety, especially refers to the operator who are directly or indirectly involved in this particular CNC machines. So along with the preventive and predictive and proactive approaches, the reliable center maintenance philosophy include knowledge-based diagnostics of samples to incorporate learning component within the programs. So they are basically provide the knowledge-based diagnosis with reference to designs, with reference to improvement, with reference to the reliabilities, with reference to maintainabilities, with reference to availabilities, so that the production cost or maintenance cost will be decreased, and the maintenance time also decrease, and the machine health and safety will be increased. So that is why most of the cases, those who are already initiate this reliability center maintenance in their operations. So let's understand the different objective of your reliable center maintenance. It provides the methodology targeted on the system functions, the failure rate relating to the functions, and in a particular to affect or the dominant function system failures. The RCM provides the structures and logical approach to determine the maintenance requirement of physical asset and its operating context. And the RCM is a method for developing and selecting the maintenance designs, alternatives based on the safety, operationals, and economics criteria. So let's understand what are the unique features of your RCMs. First one is preserve functions, and the second one is identifying failure modes that can affect the function of machines. The third one we have that is known as prioritize function needs versus failure modes. And last one is select only applicable and effective tasks. So these are the four number of unique features which is included in case of RCM objectives. So let's understand the methodologies. First you have to select the systems, and each system has number of data. The information must be collected, and these information are linked towards the system boundary definitions. So system boundary means each system consists of number of elements, and each number consists of a large volume of data. So before iteration of this data or estimation of these data, you have to make a boundary conditions. So next one is you have to go for system descriptions and functional block diagram should be there. For example, you are using a steel production systems, that should be represented in the form of functional block diagrams. If you are using a that is known as sugar production systems, each production system process should be represented in the form of functional block diagrams. Then after to go for the system function and functional failure areas. So in case of that is known as system function and functional failure areas, you have to identify the failure mode and effect analysis. So most of the cases, many companies go for root cause analysis or root cause failures analysis by the help of Pareto analysis, which is also known as fishbone analysis. And after fishbone analysis, you have to identify the fault tree analysis. So after taking the fault tree analysis data, you have to task selection should be done for your reliable center methodologies. I repeat, in case of reliable center methodologies, first you have to select a systems and collect large amount of information. Then made a system boundaries. The third one is system boundaries should consist of system descriptions and functional block diagram should be there. Then you have to go for each system functions and functional failures. So for functional failure, you go for failure mode and effect analysis, and from failure mode and effect analysis, you go for fault tree analysis, and finally task should be selected for the reliable center maintenance. So the next we have to understand what are the basic benefits of reliable center maintenance. The first one is, as I told, it is combined preventive, predictive, and proactive maintenance strategies. That means it's provide a high qualities, high cost effective maintenance plan in the less times. The assurance, second point is assurance that all maintenance important parts and their failure mode are critically considered in the development of maintenance program or schedules. The third benefit is increased probabilities that the level and the content of the maintenance requirement is optimally specified. The fourth one is provide the basic for the routines, online information sharing among engineering, operations, and the maintenance staffs. The next benefits we have longer useful life of expensive assets, improved safety of equipments and the plant personnels, better environmental protection and sustainability should be achieved. And the last one is improve operational performance in terms of outputs, qualities, and customer service. So these are the basic benefits of implementing the reliable center maintenance in your organizations. Then the next is misconception about the RCM because it's combined the three most important objectives. As I told, it is preventive, predictive, and proactive maintenance strategies. The first is RCM will eliminate the breakdowns. So it only help in case of reducing the number of breakdowns. And the second misconception is that RCM is way of replacing and attending the parts before it breaks. So if you go to the said reality, the RCM is much bigger than that. That means budgeting, failure analysis, eliminating the excessive resources use, permanent correction of the problem area should be considered under the replacement and attending part before it breaks. Misconception about the RCM is all the RCM system are same can be copied. So RCM systems are tailor-made, designed to keeping in view of equipments, age of equipments, product manufacturings, type of services, servicity of the use and skill of operators. The fourth one is that RCM increase the workload and expenses. So it increases the off times, reduce the energy uses, reduce the on-plant event in maintenance management. And the last one is unskilled worker can perform reliable center maintenance. So for worker, that is known as skilled people must be looped in case of greater return in case of RCMs. So with good the procedures, the training to unskilled worker can be do many routine tasks. So for greater returns on investment, skilled people must be in the loop to provide better maintenance management by the help of reliable center maintenance. The next topics we have pitfalls in implementing the reliable center maintenance. So the common problem leading to the lack of success of RCM can be summarized as follows. The first one is if you are not providing the sufficient data, that means insufficient equipment failure data should be pitfall for the implementing of RCM or disadvantage for the implementation of RCM. Then poor training or inadequate training should lead to implementation of RCM methodologies and poor result in case of preventive maintenance and predictive maintenance efforts. Lack of understanding at the top level of management. Insufficient staff for the programs. The next is short-term RCM efforts, lack of focus, especially reference to maintenance management department, and short-term equipment focus. So these are the pitfalls whenever you implement in case of RCMs in your organizations. So next, just review the things before summarizing. So today's session we are basically focused upon that is known as the reliabilities, the concept of reliabilities, the maintainabilities, and the reliable center maintenance, and their methodologies and implementing the RCMs with reference to reliabilities, with reference to availabilities, and with reference to maintainabilities. And we have to already understand the misconception about the RCMs and pitfall implementing the RCMs. So in case of reliability, as I told, the probabilities they basically give the performance intent to function during the times, and reliabilities basically measures the mean time between failures, and it is also known as the average time between two consecutive failures. Similarly, in case of availabilities, it is highly reliable as the failure rate is negligible and it falls only one or two times in a given period. And in case of maintainabilities, it will start from the characteristics of designs, installation, which express the probabilities that an item will be restored to a specified condition within a given period of times. So, by the help of this reliabilities, maintainabilities, we have to understand the designs, define the maintainabilities, implement, modify the maintainabilities, and how the maintainability affect the corrective maintenance and preventive maintenance. And corrective maintenance affect the availabilities, and preventive maintenance improve the availabilities, which impact upon productivities or productivity cost. So the next part we have understands the fundamental concept of that is known as reliability center maintenance, which basically a strategy employed by combining preventive, predictive, and proactive maintenance technologies to increase the confidence of a machines will operate dependably over the extended life cycles. And we have also understand the different classification of reliability center maintenance, such as reactive, that is preventive maintenance. The next is condition-based maintenance, and the last one is proactive maintenance. So the next important part we have to understand the reliability. That means how the reliability focus upon probabilities of based concept, increase the durability of machines, then increase the dependabilities, reduce the downtime and quality over the times, and the last one is availability of machines. The next is we are also understanding how this reliability is implemented. We are basically using the Pareto analysis for segregation of critical components, parts which fails too frequently, which have greater impact on the availability of the equipments. That means we are using 80-20 analysis, where 20% of the parts account for 80% of failures. So the next important part we have to understand the approaches of uses of enhanced reliability. That means we are using thicker materials, strong materials, better material for light proposed equipments, and we also go for simple and standardized components to reduce the reliability, so that the availability of machine will be increased for a specific time period for production and operation management. Then to understand the measure of that is known as reliabilities, we are also understand the graphical representation of field of reliabilities. That means we are comparing product failure rates versus the time. So here we have to focus upon the overall life cycle of assets, failure rate of overall production of asset over times. And the last one is by the help of this graphical presentation, we have to understand the reliability of asset. That means we specifically focus the reliability failures, normal life, and wear sections. Moving to next ones, we are also understanding the basic concept of calculating the availability. That means availability equals to mean time between failures divided by mean time between failures plus mean time to repairs plus mean time waiting for the space. So if you go for supply availabilities in case of mathematical expression, as in case of input and output functions, so availability equals to the function of reliabilities, maintainability, and supply effectiveness. So the next important part we have to understand the basic fundamental of reliability center maintenance. That means how the decision areas related to condition-based monitoring, real-time monitoring, proactive maintenance, reactive maintenance, and preventive maintenance are implemented under reliability center maintenance. So these are basically implemented in various unique features like preserve functions, identify failures that affect the function, the characterize functions need by failure modes, select only applicable and effective tasks, and we have already understand the RCM methodologies, how the systems selected, collected data, system boundary definitions, system descriptions, and functional diagrams lead towards the selection of tasks. Thank you.